All right, we have foreshadowed asymptotes quite a lot. We've talked about them a little bit. Let's get into talking about them in detail. So an asymptote is a line that a curve approaches as it heads towards negative infinity or positive infinity. So as it moves along, it gets closer and closer to this line. It never actually touches it. So you can see it when you look at the graph. You can see that this starts to kind of level off and approach this value of 0, like I said in the previous video. You can see that this one levels off up here and approaches this arbitrary line. Well, I suppose it's not arbitrary, but it approaches this line of y equals 4, where it's getting closer and closer and closer to it, but it never actually gets there. But let's look at algebraically why that happens. So this says, notice that as your input into this function, f of x equals 2 to the x, becomes a smaller and smaller value, your output becomes a teeny tiny fraction, but it's never actually going to reach 0. So let's just play around with it for a second and make sure that you agree. So f of -1, if I plug in -1 to this function f of x equals 2 to the x, I get, remember that a negative fraction means it's on the wrong side of the fraction bar. So that means that this becomes 1 over 2. Okay, so at -1, I'm at about 1/2. That matches. F of -5 means I'm really got 1 over 2 to the 5th, because that negative fraction, that negative exponent means it flips, and 2 to the 5th is 32, so that's 1 over 32. That's going to be this teeny tiny, teeny tiny, tiny, tiny little fraction, and you can't even tell that it's not touching that 0, but we just know 1/32, though it is tiny, it is not 0. If I go up to 2 to the -10, that's going to be 1 over 2 to the 10th. And 1 over 2 to the 10th equals 1 over 1024. 2 to the 10th power is 1024. Okay, that's a really small fraction. Such a small fraction that it's impossible for me to show it to you on this graph unless I zoom in microscopically close, but it's still not 0. Okay, and that's going to continue to happen no matter what you do here. You're going to keep on getting smaller and smaller fractions that are never actually going to get to 0. Now, it may get so small that your calculator just says, oh, darn, I'm just going to tell you it's 0, and it's going to sort of round it to 0, but it really truly never gets there. Okay, when we look at this one, it looks like it's approaching this line 4. So let's look if the algebra bears out there. So if we plug in 1, then we should be landing about right here. Okay, so -1/2 to the 1 power is just -1/2, plus 4 is 3 1/2. Okay, well, 1, 3 1/2, that looks about right. If I put -1/2 to the 5th, well, -1/2 to the 5th power, if you put that in your calculator, it ends up being -1 over 32, because it ends up being 1 to the 5th over 2 to the 5th, and we already said 2 to the 5th is 32. Plus 4 is going to be 3 and 31/32. Okay, so that's getting really, really close to 4, because 31/32, that's almost a whole. So I'm almost at 4, still not quite there. When I go to this last one, -1/2 to the 10th, again, you're going to distribute this 10. This is going way back to Unit 1, thinking about those exponent rules. But you're going to distribute that 10 to the 1, so it's -1 to the 10th over 2 to the 10th, which is, let's see, plus 4, which is -1 over 2 to the 10th is 1024, plus 4 is going to give us 3 and 1023 over 1024. Okay, guys, that's almost 4, right? But it's still got that tiny little 1024th that's keeping it from actually equaling 4. So you can see that the algebra does bear out that it gets close, but never actually touches it. You don't have to do that little plugging in game every single time. You can absolutely just look at the graph and say, hey, look, that's approaching 0, or hey, look, that's approaching 4, depending on the problem. If you're looking at this line, we say that the asymptote is the line y equals 0, because remember that horizontal lines, we put y and then the value of y there. So this asymptote is at y equals 0. This asymptote would be the line y equals 4. So that's your official answer. Y equals 4, y equals 0 for our 2 examples. Okay, so when you report an asymptote, you give the equation of that line. You can also look at it just algebraically. You've got this basic function, y equals a times b to the x. If there's nothing being added there, then you can know that the asymptote is 0. Notice that in this example 2, we had that little plus 4. That's what made the asymptote be 4, because it basically took this graph that would have been running right along here, and it shifted it up 4. It just added 4 to it. So it brought it up 4. If I had subtracted 4, then it would have brought it down 4, and I would have been approaching -4 as my asymptote. So you can look at the equation if you're given an equation and really quickly tell what that asymptote is. This doesn't have anything added, okay? So my asymptote is y equals 0. This one has 4 added, so my asymptote is y equals 4. Easy enough. All right, so what I want you to do right now is I've got a few practice problems for you to do that are specifically asking for the asymptote function. So go ahead and do those practices before you move on to the next video. That way we can get some practice on asymptotes before we mix in all those other characteristics. All right, let us know if you're having any trouble.